Alright, my name is Dave Ratt, and I'm going to talk a little bit more about polarity. This is the third video. I've been asked quite a few questions. One of them has to do with main PA. You have a main PA here, pointed that way. You have stage here, you might have some monitors here, pointed this way. Do we put the main PA in polarity or out of polarity with the stage monitor? In order to answer that, let's take a look at the output of a speaker. Let's look at a subwoofer. We have a double 18 sub, let's say, and we'll port that sub back to the speaker. It comes out there, front there, side view. Okay, so porting. Speakers tend to have a little hole in them, so it's low end, to tune the low end. That porting is basically set up so the output of the rear of the speaker is delayed or resonant in such a way that it sums with the front of the speaker, extending the low frequency. So we get more emission. If you look at the output of a subwoofer, for all practical purposes, we've heard it a bunch of times, output of a subwoofer is omni. Which means that we're in polarity everywhere. What if that sub's a cardioid sub? Because we're seeing a lot more cardioid subs. There's two different cardioid designs. One of them both of them involve some sort of rear-facing speaker. One of them would be basically we just time delay the front, so we delay the front, so it waits for the sound here, and then the sound comes out the front in time with this, and we get some extra summation here in front, and this one comes out later, this is earlier, we get some issues, so this gives us some cancellation back here. Not out of polarity, just a reduction in volume. The other type of cardioid sub involves using an in polarity signal in front and out of polarity at a reduced volume behind. The sound that comes out the back, this speaker attempts to output a canceling sound which causes there to be a reduction in volume behind it. Now we do have some out of polarity sound. If the speaker is designed properly, this out of polarity sound is only just enough to cancel out the sound from the front. So, regardless of the cardioid sub design that you're using, the output behind it, everything's in polarity in front, and even if there's an out of polarity sound behind it, it's not significant in volume to be out of polarity. It shouldn't be an out of polarity sound. It should just be a reduced positive polarity sound. So, for all practical purposes, we can treat all loudspeakers as in polarity, regardless of whether you're behind it or in front of it. Well, that solves the whole monitor problem. So now we got our main PA here, we got our monitor here. This points that way, that points that way. Everything's in phase. Basically, the sound that wraps around here is in polarity. The sound that comes out here is in polarity. Yes, there's some time offsets, but for all practical purposes, there's no reason to reverse polarity on either the mains or monitors. Which means, back in our drum fill where we reversed the polarity of the drum fill so that we were in phase here, we did a polarity reversal. We would also want to do that polarity reversal on those same channels out front if you want things to sum correctly. So the monitor engineer and house engineers would follow the exact same polarity plan for optimum results. What are the negative effects of not following that? Theoretically, the low end from the main PA, if this distance isn't too great and if the volumes are fairly similar, would cause there to be some cancellation, and basically the main PA would kind of suck the power out of the monitor rig and make the monitor sound more distant to the performers, and then they would not be happy. Oops, wrong one. Maybe sad. Alright, another question that I was presented with similar to that is, what about polarity when you use two kick mics? So we put a little kick mic inside of here, come out there, and we've also got another mic out here. We run that. do we run, what's the polarity of these? Well, if we get rid of all of the extra crap here, we just look at the drum with the beater hitting it. We got sound coming out. And we put a mic here, and it comes into that mic. We put a mic here, it goes into that mic. It hits both mics. There's no reason to reverse polarity on one of those mics unless you want to get rid of all the low end on your kick drum. Because that's what will happen. If you reverse polarity on these mics, and the mics are reasonably full range, you haven't high passed one or the other, the low end will cancel out. For the most part, if you want those two mics to work together, kick mics in polarity. If you really want to do it right, theoretically, you could measure this distance from the sound source to the mics and time delay. You could make this one go back in time to here, and they'd get even better summation as long as you don't reverse polarity. Alright, so that takes care of kick mics. They're both in polarity, no reason to switch them. What about stage monitors? I've seen this done before, much to my puzzlement, if that's a word. Where you got stage monitors in front and behind the singer. Audience people are out here. And they were putting polarity reversers on the rear wedges. Why? I don't know. As you can see, you're at the summing point. There's no reason to put the reverse on the rear wedges unless you want there to be less sound in the middle. Or you have too much low-end summation in the middle. But to solve that, you would just high pass the low end on one set of wedges. And that solves the low end thing without giving you the center point cancellation. Alright, so even though most of the time we do want everything in polarity front of house to monitors, on the first two videos I showed you how to determine what the polarity should be on the various mics on stage. What about, everything is not always in polarity from every mic. There are always exceptions to the rule. One speaker design that has an out of polarity component to it would be a open back guitar cabinet. We see these quite a bit, where you've got an in polarity out of the front of the speaker, and the back of the speaker with the out of polarity sound is radiating behind. If you put a mic on the front of that, it would be the opposite polarity of a mic miking the rear, because the sound of the speaker is reversed coming out the back. You can think of that if basically you were to put a positive pulse, the speaker moves this direction, this mic here would be the diaphragm would be moving in, the positive pulse would cause this diaphragm to move out. One of those has to be switched. If you look at the output of an open back box, it would be a figure 8 pattern. The figure 8 being in polarity in front, out of polarity behind, and off to the sides cancellation, because you would be hearing both the in polarity and out of polarity sound, and they would sum together and give you very little. Another interesting aspect of figure 8 mics is if you look at the polar patterns, you have omni at one end of the spectrum. You have cardioid, which basically has, this is, let's say, in polarity. This is in polarity and no polarity behind. Then you've got your supercardioids, which is in polarity and out of polarity behind. And then you've got your hyper, and it keeps going, and these null points increase. And then finally you've got your figure 8 at the other end of the spectrum, where you've got in polarity and out of polarity behind. Well, this out of polarity component is of some concern and shouldn't be totally disregarded, and it's nice to be aware of it when you're dealing with microphones. In loudspeakers, we don't really use a lot of super and hyper or figure 8 type things in live reinforcements, but it is something to consider. Alright, hope that helps solve some of the polarity questions there. And if I think of something else, I'll do a video 4 on this. If not, I'll move on to another subject. Alright.